So this is a video for Unit 2 in pre-calculus on logarithms. So part 1, we've got a word problem here. In what year will it reach 325? So that's R. So to first start, I'm going to divide both sides by 15. You can use your calculator. That's 21.6 repeating. And to solve, I'm going to either log or ln both sides so that my exponent can become a coefficient. So I'm going to choose ln. So that gives me ln of 21.6 repeating equals t over 12 ln of 2. So to isolate the t, I'm going to divide by ln of 2 on both sides. I'm going to do ln of this decimal divided by the ln of 2. And to get answer, you do second negative, and it would bring, and that's what puts in the whole 2.16 repeating. So that's 4.437 equals t over 12. Multiply both sides by 12. So times 12, 53.25. So if 2015 is the year we started, so that's in the year 2068. Okay, for number 2, equivalent to log base 2 of 256. There's a few different ways to do this. Since you have a calculator for everything, you can do a lot of typing. I could find out this exact value. I don't have a newer calculator like some of you. I don't have the log base choice. If you hit math and go to the end, I don't have that choice A, which is log base, which gives you the spot to type the base and the 256. Instead, I have to use the change of base formula, which is log of the argument over log of the base. So this equals 8. So I know that's true. This plus makes it log base 2 of 4 times 16. So let's see. That is 64, which is not 256, so that's not true. You could also do that exact value. We knew it's not -8. Let's calculate this. So this is 2 times the value squared. So this is saying 2 to what power is 4? 2 times 2, this is 4 squared, it's 16. Nope, that's not 8. That is definitely not the same. This one is 2 to what power is 4? 2 to what power is 16? Oh, that's 8, that's the same. This is the change of base formula for that. And then this is 3 times, so 2 to what power is 8 is 3. Then 2 to what power is 2? So this is not, oh, that's 8. Oh, sorry, you can't see that. So log base 2 of 8, this is 3. So then 3 times 3 is 9, minus 1 is 8. Oops, that's a check. This was 2 to what power is 2? 2 to what power is 2? That's the 1. It says there are 5 equivalent. Well, I got 4. Uh-oh. Which one did I miss? I don't know. Well, I don't think this is the same. Nope, that's not 8. I think there's only 4 equivalent. I'm going to change the directions. If I'm wrong, I'll put a comment in the video once I upload it to YouTube. All right, let's see what's next. Enrique and Carmen both rewrite the following expression as a single log. Their expressions look similar, but in some parts they're different. Could they both be correct? Review their work and identify any mistakes. Oh boy. Okay. So let's just start with Enrique. We've got a subtraction here. We've got the same bases. Oh, he factored first. So what multiplies to 12 that adds to 7 is 4 and 3. Oh, and then he separated it. Said, okay, because these arguments are multiplied, we can separate it with an addition. That's right. Oh, and then look, these are the same, that adds to 0. Okay, I think Enrique is right. Carmen, I don't know what she's doing here. Okay. She's saying log base 5 of this argument minus, you can't factor out a log. That's wrong. Carmen's not right. And then she subtracted like terms. She said 7x minus x. You can't do that. No. And no. Sorry, Carmen. Are their final expressions equivalent? No. If they're not, show how you could correct the mistakes. Okay, well, Carmen, this minus she could rewrite as division of the arguments. Then she could factor the numerator and divide those expressions to 1 and be left with log base 5 of x plus 4. Now that Mrs. Weiss's work, sorry Carmen, is right and matches Enrique's answer. Expand each log. All right. We have multiplication here, so that's log base 6 of c to the 5th plus log base 6 of the 3rd root of a. But we're not done. This exponent has to become the coefficient. This is an exponent of 1/3 because of the radical. Okay. I think I'm going to simplify the argument first. This is 5 to the 10th and 2 to the 5th. This exponent can go to both those pieces. So then that's ln of 5 to the 10th minus ln 2 to the 5th. So that's 10 ln 5 minus 5 ln 2. I'm going to do the same thing with this 6. We've got log base 5. That's going to be x to the 18th, y to the 6th. So we get 18 log base 5 of x minus 6 log base 5 of y. Multiplication again. We're going to add the log expressions. Then the exponent becomes the coefficient. The radical is a fraction exponent. Okay, for 5, we've got u, v, and w squared. So that's log base 2 of u plus log base 2 of v plus this exponent will become the coefficient. This 6th power, I'm going to apply to both pieces of the argument to start. When you have a power to a power, you multiply, so 3 times 6 is 18. So that's 18 log base 9 of 12 plus 6 log base 9 of 7. I'm going to take this squared to both pieces. That's going to be x to the 6th. And then this cube root of m squared, well, that's m to the 1/3 squared. So that's m to the 2/3. So we get 6 log base 9 of x plus 2/3 log base 9 of m. You better be a pro at these problems. There's a lot of practice here. 20 becomes the coefficient. 4 becomes the coefficient. And that 2 becomes the 7 of z. The square root is an exponent of 1/2. I think this is the last one of these. Ooh. 3 becomes the coefficient. Oops, I already wrote log. Uh-oh. 2 becomes the coefficient. And the 1/2 becomes the coefficient. All right. Ooh, now we're going to go the other way and we're going to condense them. Okay, all of this divided by 3, I'm going to make as a coefficient of 1/3. That way it looks very clear that I know that that's going to come up and be the exponent. All the adding means multiply. So we got x to the 1/3, y to the 1/3. So that's ln of z. We can do cube root of x, cube root of y. It's the cube root of xy. It would also be okay to do it as cube root of x, cube root of y separate. All right, in 12, the 3 is going to come up and the 9 is going to come back up. So x cubed y to the 9th. And because of the adding, I multiply my argument. Subtraction now. So that means the arguments are going to be divided. Here's that tricky notation again. This is like 1/2 log base 9 of x plus 1/2 log base 9 of y. Everything is added. Oops. So that's z, x to the 1/2, y to the 1/2. Which you can write, I keep doing that, sorry, it's base 9 of z square root of x times y. 4 comes up, 6 comes up. Minus is the division. I guess you really could do that value in your calculator if you wanted. Nah, it's not very nice. I'm just going to leave it as a fraction. Oh, here's that 1/3 again. So you've got log base 7. It's really hard to talk and concentrate on what you're writing at the same time. Of z times x to the 1/3, y to the 1/3. This is log base 2 of x squared y to the 10th. Adding made these multiply. All adding, so it's all going to be multiplied. X times x plus 1 times 4. It really doesn't matter the order that you multiply those arguments in. I just think it looks nicer with the coefficient of 4 in the front. You could distribute that and make it 4x squared plus 4x. So minus is going to be division. And let's see if we can simplify. I have a hunch this numerator factors. So our final answer is going to be log base 2 of x plus 3. I bet the same thing happens in this one. So let's factor this as we write it. Multiplies to -10, that adds to 3, would be 5 and -2. Yep. So it simplifies. Solve and check for extraneous. The argument cannot equal 0 or negative. So let me say that as the argument needs to be greater than 0. Oh, man, Miss Weiss, you should have kept reading. It says it. All right. When you have the same log base and it's an expression equals an expression, you can drop the logs. And now it's an algebra 1 problem. Let me add the 3x to the left and subtract the 8 to the right. Will 2 make this argument negative? No. Will it make this one? No. So that's our answer. Log, same log base equal. So we can say x plus 6 equals 3x minus 6. So we get 12 equals 2x. 6 equals x. Uh-oh, I already see a problem. If we do 3 times 6 minus 6, oh no, that's positive. We're okay. And this one positive, okay, so 6 is our answer. We're okay. No problems. Holy cow, there's a lot more solving. All right. Number 23. The log bases are the same. M equals 3. If I plug that in, I get a positive value. 9, positive, we're good. I'm going to add my 5r to this side. I'm going to add my 4 to this side. So we get 1/3 is r. Don't panic, it's a fraction. You got a calculator, no problem. Sorry for the glare. All right, so if we do -5 times 1/3 minus 2, uh-oh, we get a negative. So this is no solution. We've got log with the same base. So I can drop my logs, but now we've got a p squared, which is a quadratic, which means I'm gonna have to factor. So I'm gonna move everything to the left so that I get my equation equal to 0. And now what multiplies to -5, that adds to -4. Then I'm gonna set each factor equal to 0. So I get p is 5 and p is -1. Now 5 plugged in here is 25 minus 7, that's good. 20 minus 2, that's good. So 5 is an answer. -1, it's gonna make this -4 minus 2, which is negative, so that is not an answer. 26. We've got the same log bases, so we can drop the logs. Again, we've got these n squareds, so I'm going to move everything to the right so I get a positive n squared. So what multiplies to 24, that adds to 11. So we get n is -8 and n is -3. Okay, so -8 squared is 64. Times 2 is definitely going to be more than -24, so -8. Let's check it over here. Got to check on both sides. Okay, that's positive, we're okay. Then we got to check -3. Uh-oh. Negative, not okay. A negative argument, not okay. Got another quadratic, so I'm going to move everything to the right. Oh, it's just like the last problem with the factoring. Oops, it's an 8. So x equals 3, x equals 8. There's no way either of those will be positive with these, I'm sorry, negative with these two positive values, so both are our answers. Same log bases again. I'm going to add the 2m squared to the left so that my m squares become positive. So we get m squared plus 5m minus 24 equals 0. So negative 24 and positive 5 is going to be positive 8, negative 3. And let's plug them in. Let me show you with the calculator. This negative m squared is going to be negative of m squared. That is negative, so negative 8 is not a solution. So negative of 3 squared plus 15, good. 24 minus 2 times 3 squared, good. Oh, finally, something different for 29. No log base is the same on both sides, so instead I'm going to divide both sides by negative 9 to isolate my log. Then I'm going to change it to exponential. 11 squared equals 2m. And then divide by 2. So 121 divided by 2 is m. Do the same thing here. I'm going to isolate the log. And then 2 to the first equals a minus 1. 3 equals a. And if I plug that in there, I don't get a negative, so we're good. Yay, last page. 6 more problems. Change it to an exponential. That will not make that negative. Ooh, 32. We've got 2 log expressions on the left. We can't just drop logs yet. First, we have to combine our arguments with multiplication. Then I can drop the logs. So if I distribute this, we get x squared minus 8x equals 20. I'm going to move the 20 to the left, and I'm going to factor. So let's do negative 10 and positive 2. So already with this x, negative 2 is not a solution because that makes that argument negative. 10 will make everything else positive in the argument, so that's our answer. For 33, again, we have to combine the logs on the left before we can do anything. Now we have log equals log, so we can drop the logs. I'm going to multiply both sides by 6. Subtract 5. There's no way, oh, sorry. There's no way that 115 is going to make that negative. That's our answer. Another multiply the arguments problem. I'm going to distribute my x. And I can eliminate the logs since they're the same on both sides. Subtract the 50. And factor. What multiplies to negative 50 that adds to 5? Oh, we're going to do positive 10 and negative 5. Set each factor to 0. Sorry that's shaking so much. This is a wobbly table. So negative 10 is not a solution because of this argument, but 5 will work everywhere. Make the arguments greater than 0. Subtraction means we can divide our arguments. So you get, x plus 2 over x minus 5 equals 10. Let's cross multiply because we've got a fraction of variables. So we got 10 times x minus 5 equals x plus 2. Distribute the 10. I'm going to subtract the x over here and add the 50 over here. And then we can divide in our calculator. And that doesn't reduce. So x is 52/9, which is 5.77-ish. That'll be positive, so that's our answer. And last but not least, we can divide our arguments again because of the subtraction between the log expressions here. We can drop our bases, cross multiply, distribute, and move my x's to the left and my numbers to the right. So x is 26/5, which is a little more than 5, so that'll be positive, and that'll be positive. The end.